Hello, this is Guan from COPL University Laval, Canada. And today I'm going to present some of our recent study on 5G service overlay in WDM optical access network with the colorless smart edge based on silicon photonic microring modulator. And I would like to say thank you to my co-author Hafel, to Professor Wei Shi and Professor Leslie Ann Rush for their contribution to this work. So here's the outline of this presentation. First comes the motivation of the proposed scheme, which is followed by the scheme that has been proposed. And later I will introduce the chip that we fabricated, as well as the experimental setup and the results. And finally comes the conclusion to this presentation. So the motivation of the proposed scheme actually comes from the time of 5G. Because in 5G time, we need to deploy more cells or get cells more dense to support higher throughput for new radio and for many other goals. And for infrastructures like WDM-OAN that has been deployed as the one here, we need to reuse it to accommodate 5G services with only minor hardware upgrade. So you see that this is a WDM service, OAN, as well as fiber to the home wild users. And we upgrade the setup a little bit like this. First, we embed the smart edge at the distribution network, and then we overlay antennas at the fiber to the home users to serve the local area or the neighborhood, or we can build up dedicated antennas for the operator to serve the facility. But here comes the question: how are we going to overlay 5G service? Firstly, is that because we know that the carrier and the signal are already dedicated to the conventional broadband users, which carrier are going to use to carry the 5G service? And the second question is that how to modulate the 5G service? Well, even we can address these two questions, there are still problem is that how can we eliminate the influence of the overlay of the 5G service onto the conventional WDM broadband service as well as other WDM bands? So our answers to this question is that first we are going to use the carrier, but we are going to generate new carriers, and then we are going to modulate the new carriers with 5G service with the help of microring modulator, silicon-based. So we see that we first generate two new subcarriers here, and then we use a modulator to modulate the green and blue, which are the 5G services. And also we can do the WDM, we can solve the WDM overlay with microring modulators because it's wavelength selective. So this is the system that we overlay. And we see that the WDM channel 1 and 2 are both overlaid of 5G services, and then they are separated to their respective destined ONU. And the advantage of the proposed scheme is that first, the throughput is higher because we generate new subcarriers and new spectrum that can be used. And the latency of this new spectrum is also low because we overlay the 5G service at the smart edge. So there's no transmission on the feeder fiber, which is usually long, and the latency cost is usually higher. So avoid the involvement of the OLT, so the latency is lower. And I also claim that the cost is also low because first we reuse the WDM OAN, so it's gonna be based on the already there infrastructure, and also the power efficiency of the new proposed scheme is also low. The power consumption is also lower because the microring modulator we use is always less power consumption than other competitors like silicon Mach Extender modulator. And we also claim that the proposed scheme is compatible to WDM cases as indicated by the figure. So the proposed scheme based on microring modulator is like this. We cascade a lot of microring modulators here. We group them into groups of 3. So each group is for one WDM band. And in that one WDM band, there are 3 microring modulators. The first one is to generate the subcarriers. See the blue and green subcarriers here, and then we use 2 other microring modulator to overlay the 5G service like the blue and the green. So at point D, it's already the overlay of 2 services. So then the signal is fed to the second band of WDM. And after this group, we see the service is overlaid to the second WDM band. And then the full spectrum is passed to other WDM bands, to other groups of microring modulators, and then for the overlay of other WDM bands. So we fabricate this device with the help of IME Singapore, and then the profiles are shown here. This is the top view, and this is the cross-section view. And this is the photo that we fabricated. The broadband service and the main carrier are fed from this port, passes through the microring modulator 1 for the subcarrier generation, and then the microring modulator 2 and 3 for the 5G overlay, and then fed out. So the microring chip is here. Well, the first microring modulator is driven by a 20 GHz clock to generate subcarriers, and then 2 other signals are fed to the microring modulator chip, with driven by the digital to analog converter, and with the help of BIOS Ts here. So the heaters here are used to control the microring modulator working bandwidth, so microrings and working destined band. And the service has dropped with wave shaper, with the filter profile depicted here with the dashed rectangle. And this is the OFDM baseband 1, OFDM baseband 2, and 2 other 50 GHz are used to drop the 5G services. Well, I forgot to say that the broadband service are generated at the OLT with 2 channels with 2 laser diodes, and the broadband service is overlaid with the other 2 channels of the converter. So when the services are overlaid to WDM band 2, you see this spectrum. So the first WDM band is left not influenced, while the 5G service are overlaid to the band 2. So we show the experimental results. Firstly, it is 100 GHz to WDM channels. And we see the red is the WDM channel is the OFDM service in the first WDM channel, while the blue is in the second WDM channel. And there can observe a little penalty here. And this could be attributed to, the introduction of a service that hasn't been optimized because we didn't use feedback control to control and stabilize the microring modulator. And this is left for future research. And the 5G service that dropped with other profiles, wave shaper profiles, with bandwidth of 15 GHz. And we see they reach the threshold of the FEC at a very low received power. So this is the 5G service overlay to the second WDM channel. And we similarly see the 5G service drop below the FEC threshold at this level. And still we observe very neglectable power penalty due to the overlay of the 5G services. So the red one is not influenced, and the blue one is is the overlay. So the conclusion is that we propose a new silicon photonic scheme for 5G service overlay in WDM OEN, and we cascade the groups of microring modulator for different WDM bands, and each group consists of 3 microrings, one for the circular generation and the other 2 for the 5G overlay. And we fabricate a chip and experiment and validate it in the WDM case. And the proposed device, as claimed, is very integrated, compact, and power efficient. So I would like to acknowledge NSERC Canada, Prompt Quebec, Thales, and Aponix for their support to our start. And thank you for attending.